Okay, today we are going to discuss. I am going to explain the topic. What is that? Cells. You write down cells, subcells, subcells, and orbitals. And orbitals. So this is our topic. We are going to discuss. See, in any atom, generally, in any atom, generally electrons in any atom generally electrons are revolving around the nucleus electrons are revolving around the nucleus in circular paths which are called orbits or energy levels or cells. So listen carefully. So our topic is cells, subcells, and orbitals. We are going to discuss. So before going to understand this concept, as a chemistry student, you know this. In any atom, electrons which are revolving around the nucleus in a circular path. For example, this is the center of the atom, nucleus. Nucleus carries each charge, positive charge. So in nucleus, positive charge is there. Electrons, what happened? Electrons are revolving around the nucleus in a circular path like this. For example, other electron revolving around the nucleus in a circular path. These circular paths, what we call these circular paths we call as orbits, and also energy levels, and also cells. Whatever it means, all are right. Orbits, energy levels, cells, all are same. So oftenly we use cells. So what do you mean by cell? That means the revolving around the electron revolving around the nucleus in a circular path. Those circular paths considered as cells. So these cells are represented with English letters, capital English letters K, L, M, N, O. Right now, cells are represented. Like K English letters, like K, L, M, N, O dash dash R. N is equal to 1, 2, 3, 4 dash. So cells are generally represented with English capital letters. What are those? Capital K, L, M, N, and also 1, 2, 3, 4. Anyone is right. You can express cells in English letters or 1, 2, 3, 4 numerical numbers. So for example, see, this is nucleus, first cell, this is first cell, second cell, third cell. So this cell is called K, L, M. If present another cell, that is N. Okay. So this K is nothing but first orbit, first cell. N is equal to 1. Here N is equal to 2. Here N is equal to 3. Here N is equal to 4. You write this. So here one word I tell you, you remember. Here small n. What is that small n? You know, the small n is called principal quantum number. Principal quantum number. This is called what? Principal quantum number. The small n is called what? Principal quantum number. Okay, the small n is called what? Principal quantum number. That means here principal quantum number represents what? Cells. It represents cells. So principal quantum number indicates what? Cells. That thing you remember. The small n is principal quantum number. It represents what? Cells. So n is equal to 1. This is first cell, this is second cell, this is third cell, this is part fourth cell. So another notation we call as first cell is called K cell, second cell is called what? L cell, third cell is called M cell, fourth cell is called N cell. Okay, then cells are divided into subcells. Cells are divided into subcells. Cells are divided into subcells. Those are S, P, D, F. Those are S, P, D, F. What are SPDF subcells? You know, SPDFs are subcells. Okay, that means from that what you can understand. So electron which is revolving around the nucleus in a circular path, those paths we call as what? Cells, which are represented by English letters, capital letters K, L, M, N, or N is equal to 1, 2, 3, 4. N is called what? Principal quantum number. Actually, it was proposed by the scientist Bohr. That thing we will study in higher classes. So this principal quantum number N represents, indicates what? Cells, number of cells. So after cells are again divided into subcells. What are those subcells? S, P, D, F. So SPDF are called what? Subcells. So S is a subcell, P is a subcell, D is a subcell, F is a subcell, and one more, G is also a subcell, F is also a subcell. These subcells are present in what? Cells. Subcells are present in cells. Okay. Next, subcells contain different orbitals, as the following. See here, thing you try to understand. So the circular path, electron circular path, we call as cells. You know, cells are divided into subcells. Again, subcells are divided into orbitals. Okay. So here subcells contain different orbitals, which are shown below as the following. So you write here. Come on, you write out. You write down. So for example, you know already what is this? S is a subcell. You know. S means it is a subcell. You know, subcell. So S is a subcell. It contains one orbital. So S subcell contains one orbital. S subcell contains one orbital. So that is That orbital we call as s orbital. That orbital we call as s orbital. Okay, S is a subcell contains one s orbital. One s orbital. Here P subcell contains three p orbitals. Three p orbitals. Three p orbitals. P orbitals. Here, those are px orbital, then py orbital, then pz orbital. So P subcell contains how many orbitals? Three p orbitals. You know three p orbitals, px, py, pz. So I can show for your understanding. I have to show like this. See, this entire box is nothing but what P subset. P cell, actually P subset. This is called P subset. Okay. In P subcell, how many orbitals are there? Three p orbitals. These single parts are nothing but orbitals. These are orbitals. P is a subcell. In this px, py, pz. These are nothing but what? Orbitals. Here, how many orbitals are there? Px is one orbital. Py is second orbital. Pz is third orbital. Px, py, pz, all orbitals collectively called as subcell, that is called P subcell. Have you understood? Okay, then in the same way, D subcell, write down D subcell contains 5 d orbitals. 5 d orbitals. Those are dxy, comma dyz. While representing x, y, yz, just you can write as a subscript. You can write at bottom dxy, dyz, dzx, dx square minus y square, and dz square. So these are the 5 d orbitals present in D subcell. I can show you. First you write down. So I want to show here. Actually, see, look here. This entire box is nothing but what? D subcell. This is total box is not D subcell. For example, let us you think this complete subcell is not one floor. You feel it is one floor. In floor, what happens? There are rooms. For example, everyone can have home, no house, no. In that house, there are number of rooms. So, for example, if it is a home or it is a house, here that house contains number of rooms. How many rooms are there here? 5 rooms. So these rooms are called what? These rooms are called what? Orbitals. So here this is dxy, dyz, dzx, dx square minus y square, dz square. So each one, for example, each box is called what? Orbital. Total house is called subcell, you know. Total box is called subcell. That box is divided into 5 small boxes. Each small box is called orbital. D subcell contains how many orbitals? 5 orbitals. What are those? dxy, dyz, zx, dzx, dx square minus y square, dz square. Okay? Completed your writing? Then one more subcell is there. What is that? F subcell. You write down F subcell. F subcell contains seven orbitals. Seven orbitals. Those are not picturized. Not picturized due to its zigzag structure. Due to its zigzag shape. So what do you mean by zigzag? Zigzag in the sense disorder shape. Due to disorder shape, we cannot picturize those f orbitals, even though f subcell contains how many orbitals? That thing you have to remember. F orbital and f subcell. This whole box is f subcell. F subcell contains seven boxes. 1, 2, 3, 4, 5, 6, 7. Okay. These each and individual box is nothing but f orbital. Seven orbitals collectively called as f subcell, isn't it? Okay, have you completed your writing? Completed? Then see, I give you one nutshell mapping. You try to understand mapping. So what is that? So far we have been studied and explaining what is that atom. Atom contains cells. What are those cells? K, L, M, N. These are also represented as like N is equal to 1, 2, 3, 4. You know this. Okay. Again, cells contains what? Subcells. Subcells. What are those? S, E, D, F. Okay. Subcells. So subcells contains what? Orbitals. Orbitals. For example, S contains how many orbitals? One orbital. But what about P contains how many orbitals? Three orbitals. You know, three orbitals. P contains how many orbitals? Five orbitals. F contains how many orbitals? Seven orbitals. Isn't it? Okay, that means atom, in inner core of atom, cells are present. In cells, there are subcells. In subcells, there are orbitals. That means present in subcells. Try to understand what I am saying. Orbitals are present in subcells. Subcells are present in cells. Cells are present in an atom. Am I right? Okay. So orbitals are present in subcells. Subcells are present in cells. Cells are present in atom. Okay. In orbitals, what are present? Electrons are present. Electrons are present. Electrons are present. Okay. Here one important thing you have to remember. Each orbital accommodate each orbital accommodates two electrons only. Two electrons only. Each orbital contains how many electrons? Only two electrons. That thing you remember. Have you written this? Did you write? I want to remove. So the same thing I can picturize in a clear manner. See, you know very well atom structure. At center of atom there is a nucleus. You know this is nucleus. In nucleus only protons and neutrons are present. Neutrons and protons are collectively called as nucleons. Those are called what? Mass number. Already we studied earlier. Earlier we studied in previous class. I explained. Okay, and oftenly nucleus carries which charge? Positive charge. This is called nuclear charge. Due to its positive charge, what happens? Electrons are revolving around the nucleus in a circular path, which are called what? Cells. You know, these are called cells. See, this is first cell. I am writing this is second cell. I am writing this is third cell. Then I want to show fourth cell also. For your understanding, I want to show fourth cell. So you know this is K or N is equal to 1, first cell. This is L, this is second cell. Represented N is equal to 2. This is M cell, nothing but third cell. This is N cell, nothing but fourth cell. Okay. See, in first cell, there is only S subcell. So S subcell contains how many S orbitals? Only one S orbital. This is nothing but what? One S. Okay, isn't it? For example, second cell contains how many subcells? Second cell contains how many subcells? Two subcells. Two subs. What are those? This is S. You know. What are those? SP. Two subcells. What are those? S comma P. So I want to show here. Yes, this is called what? 2S. You know, 2S. And I want to show P. P means P subcell contains how many orbitals? 3 orbitals. So this, you know this is Px, Py, Pz. That's all. 2Px, 2Py, 2Pz. Okay. Third shell contains how many subcells? Third shell contains 3 subcells. What are those subcells? S, comma P, comma T. So I want to show here. This is S. S subcell contains only one S orbital. P subcell contains 3 orbitals. In the same way, D subcell contains how many orbitals? 5 orbitals. 5 orbitals. See, 1, 2, 3, 4, 5. This is 3S. This is 3P. This is 3D. So dxy, dyz, dzx, dx square minus y square, dz square, but need not to write that expansion form. Okay. Then in fourth cell, how many subcells? 4 subcells. S, P, D, F. So I write here S subcell, P subcell, D subcell, F subcell. See, S subcell, this is 4S subcell. P subcell, 1, 2, 3, this is 4P subcell. D subcell, 1, 2, 3, 4, 5, this is 4D subcell. Okay, like that. F means F subcell contains how many orbitals? F subcell contains how many orbitals? I think 7. 1, 2, 3, 4, 5, 6, 7. This is nothing but 4. So here N is equal to 4 means S, P, T, F subcell. S comma P comma D comma F. This is the entire atomic structure. You remember. Entire atomic structure you remember. So one more time I am explaining. Look here. So this is first cell. First cell contains only one subcell, that is S subcell. S subcell contains only one s orbital. Here, second cell contains two subcells, sp subcells. sp subcells. How many orbitals? 4. How many orbitals? 4. Third shell contains 3 subcells. 3 subcells. These 3 subcells contains S subcell contains 1 s orbital, P subcell contains 3 p orbitals, D subcell contains 5 d orbital. 5 plus 3, 8 plus 1. That means here 9. Okay, how many orbitals are there? 9. Then fourth cell contains how many subcells? 4 subcells. 4 subcells. So 4 subcells. Each subcell contains different orbitals. For example, S subcell contains only 1 s orbital. P subcell contains 3 p orbitals. D subcell contains 5 d orbitals. F subcell contains 7 f orbitals. Okay. Today I want to stop here. The remaining part I will continue in next class.